All right, let's go. All right, so down in the Art Tools section right here in our Art Tool DI Warp 9 function, we have finished it. It works. Oh boy, a 1/9 chunk of discrete units. This is out of bounds because it's very close to this number, but it's actually divisible by 9, and it's going to prevent artifacts. We moved it up from where it was previously on the bottom, and this is the power of 2 cell. We're going to multiply cells by a power of 2 that is correlated to the tile size exponent. And this is the actual cell we're on. We're going to do some remapping. We're doing some remapping. So the power of 2, right, we're going to exponentiate based on the tile size exponent. And the ith is how many subdivisions are in the power of 2 cell grid, right? So the actual cell grid is always 9 by 9, but the power of 2 cell grid is 9 by 9 multiplied by the power of 2. The thickness of our power of 2 cells is going to be the number of discrete units divided by this ith, and then which cell we're in of those power of 2 cells is the discrete internal local sample point inside of the tile divided by the thickness of one of those cells. The actual cell, all you have to do is take the cell divided by the power of 2, and you have the actual cell index on the 9 by 9 grid. And we want to do some remapping between these two things, the cell and the actual cell. The modified cell is going to be that remapped cell index. Okay, so if we're less than or equal to 3, then we're remapping to the left, and all we have to do is assign the remapped cell to cell, and then if we're out of bounds, we just clamp to 3. If we're in the middle, which is I4, so we're in the actual cell, we're in the middle of our 9 by 9, then the modified cell is just equal to the actual cell. We just directly carry it over. Now, if we are on the right side, then we have to get this overflow amount, which will be 0 if we are on tile size exponent 0. And we have to shift everything back, and then we have to cap on the left and right sides. If we're less than 0, we make it 0, and then we do this kind of Texel center-ish math, right? The cell multiplied by the discrete units, and then half a discrete unit to get this output discrete internal local. And I'm out of fucking time.